right, just as we can solve linear equations by using properties of expressions, so those were the commutative, associative, and distributive, and equations, when we used addition and multiplication properties, we can do the same for inequalities. But we have to make sure we know what those properties are, so let's test them. So first of all, what's an inequality? An inequality is when you have that little alligator sign. So we're testing the true inequality that 4 is less than 8. If we add 3 to both sides of the inequality, what is the resulting inequality? Is it true? So we have our original 4 is less than 8, and it's saying that you need to add 3 to both sides. So now we have 7. Is that still less than 11? Yes, it's true. If we subtract 4 from both sides from the inequality, what's the resulting? So let's do our 4 is less than 8, and this time we're going to subtract 4. So now I have 0 is less than 4. Yes, it's still true. If we multiply both sides by 2, what's the resulting inequality? So again, we have our 4 is less than 8. This time we're going to multiply by 2, multiply by 2. So 8 is less than 16. It's still true. And our last one, if we divide both sides by 2, so divide by 2, divide by 2. So 2 is less than 4, still true. Based on exercise 1, you might conclude that the truth values of inequalities have the same properties as the truth values for equalities, so equations. But there is one huge difference between linear inequalities and linear equations. So we're returning to our true inequality that 4 is less than 8. And if we multiply both sides by -2, what is the resulting inequality? Is it true? So we have 4 is less than 8. So this time I'm going to multiply each side by -2. And I find that -8 is less than -16. But is this true? No, it's not. This is false. So what if we divide both of them by -2? What happens? So we divide by -2, divide by -2. So now I have -2 is less than -4, which again is false. Because if you look on a number line, -2 is actually farther right than -4. So there's no way that's true. So looking at this, the addition and subtraction property is true. So everything we know is true. But the multiplication is only true if it's positive. So it only works if it's positive, and it won't be true if it's negative. So what you're really doing is you have to switch that inequality. So exercise 3 says write a true inequality and show that it becomes false when multiplying or dividing each side by a negative. So we're going to use something different than before. So let's say that I have 10 is more than 4. And let's multiply it by -2. And we see that -20 is not more than -8. That is not true. That is false. So what you have to remember is if I am multiplying or dividing by a negative number, I have -20 and I have -8. What happens here is this has to switch directions in order for it to be true. Now that we know the ways that the truth value of an inequality can remain the same or change, we can solve linear inequalities. So we have this linear inequality, 4x minus 3 is more than or equal to 5. So we have our original equation or inequality, 4x minus 3 is more than or equal to 5. So we're going to do the same thing that we always do. We draw our line. We do the opposite of what happens. So think about what's happening to x. First, it's multiplied by 4. Second, it subtracts 3. So we're going to add 3. So now 4x is more than or equal to 8. Then we divide by 4. So x is more than or equal to 2. Then it says write 5 numbers that make it true. Okay, well, 2 because of the or equal, 3, 4, 5, 6. There's 5 numbers. Now graph them on there. So let's see, I have 2, so 1, 2, 3, 4, 5, 6. So is it true that I can't do any numbers less than 2? Yeah. And it's every number larger than 2. So we give it a large arrow. Make sure that the circle on 2 is filled in to include 2 in the answer. All right, so now we have a new linear inequality. Rewrite the left-handed expression as an equivalent expression using addition. So what we're going to do is show that 8 minus 2x is more than 16 can actually become a plus negative. So we can rearrange that and make it negative 2x plus 8 is more than 16. Sorry, not 6. Yeah, 16. So solve the inequality by applying the properties of inequality. So we have our new equation, negative 2x plus 8 is more than 16. And we're going to solve. So we subtract 8 from each side. Negative 2x is more than 8. Then we divide by negative 2. What happens when we divide? This changes direction because we divided by a negative number. So 8 divided by negative 2 becomes negative 4. So pick a number that is true based on your solution and show that it makes the original inequality true. So we need to pick a number that's less than negative 4. So let's pick negative 5. So let's do negative 5. If I plug this into the equation, 8 minus 2 times negative 5 is more than 16. This double negative right here, negative 2 times negative 5 makes that positive 10, so it's 8 plus 10. Is that more than 16? Yes, 18 is more than 16. So that shows that any number smaller than negative 4 will make that true. So if we graph this, notice how it is not or equal to. So it's just an open circle at negative 4. And remember, it's everything less than, including negative 5. So we're going to draw an arrow showing everything in that direction will make it true. When we solve inequalities, we will also use the commutative, associative, and distributive properties of numbers to write simpler equivalent expressions on both sides of the inequality. So consider this inequality. It's a very, very long inequality. And we need to use the distributive, commutative, and associative properties to simplify the left and right hand. So the first thing we're going to do is distributive. So 8 times x is 8x. 8 times negative 2 is negative 16. Then we have negative 3 times 2x is negative 6x. Negative 3 times 1 is negative 3. Is less than or equal to 7x plus 4, negative 3x, and negative 3. So now we need to, I'm going to separate that. Now we need to use the commutative and associative properties. So the commutative property would be put all of the x's together and all of the constants together. Make sure that you are keeping the sign in front of what you're moving. The associative would be you could then take out negatives, whatever. I'm just going to combine like terms at this point. So 8x minus 6x is 2x. Negative 16 and negative 3 is negative 19 is less than or equal to 4x plus 1. So now we're going to solve this equation. So 2x minus 19 is less than or equal to 4x plus 1. So let's solve. We need to get the variables to one side. So negative 19 is less than or equal to 2x plus 1. Then we're going to get the constants to the other side. So negative 20 is less than or equal to 2x. And then we're going to divide each side by 2. So negative 10 is less than or equal to x. You could rewrite that so that x is on the left-hand side, but remember that the inequality still needs to be facing the x so that it reflects our original answer.